Good afternoon, everyone. My name is Christopher Mitchell. I'm from Los Alamos National Laboratory, and just want to take a couple minutes to go over some of the work we're doing for visualization and analysis at scale. So coming from the high-performance computing realm, we are starting to get inundated with large data. As was said earlier, HPC users are trying to simulate the world and the products we use within it. And so if you take a cross-section of what we run on our clusters, you'll typically see stuff along the lines of climate simulations, high-energy physics, defense problems, etc. And it's not unheard of for these simulations to be detailed enough to produce terabytes, if not petabytes of data for every run. And what we find is that obviously raw data is useless unless you analyze or visualize it. So what we've turned to is a tool called ParaView. It's a scalable open source platform that's tailored to the high-performance computing environment. And it works using data parallelism. So that lines up nicely with the large volumes of data we're getting. Also, as a byproduct of that, we get data streaming, so we can incrementally process through what's requested, and we can do multi-resolution work where we can scroll through results immediately, but we get a summary view, and then the fuller resolution pictures come in over time. So just putting an example up on the screen real quick. This is one of our plasma simulations. This is looking at magnetic reconnection in particular. For this particular run, one vector field worth of data for one time step totals out to 6.9 gigabytes of data. Now, in a typical simulation run, it's not unheard of to have hundreds to thousands of time steps running, multiple vector fields being saved, and a couple of scalar fields for good measure. And so as you can see, the amount of data that we're saving out from one simulation run adds up very quickly. So what we've had to do is initiate a project to rethink how we do I/O and ParaView to handle this problem. So as has been talked about, our current situation is we use a parallel file system to access the data over a storage area network. This is becoming more and more expensive to bring the data to the processor, and the side effect of that is that the user applications no longer are interactive. And so what we've done is we've said, okay, well, let's take the ParaView I/O system, let's rewrite it so that it uses the Hadoop distributed file system instead of a parallel file system. And we're going to go ahead and process the data in situ to where the data lies. Now, the trick to this is ParaView is not a MapReduce application. It's an MPI program. So what we had to do is devise a scheduling algorithm that would place these MPI processes on the data nodes that actually were storing the chunks we needed to access. And ultimately, we want the goal of no network transfers. And so when we actually implemented this, what we found is we got approximately a 3x improvement in read time compared to existing solutions. And so what used to take about 1.5 seconds to load per time step now started coming in at about half a second to load. Now we can start playing around with interactivity again. And as another nice byproduct of this, we started getting a more consistent standard deviation on the results, meaning that we're getting consistent read times instead of large fluctuations in how long it would take to bring in data. The graph you see on the side shows the results plotted out when it was run on 128 nodes of one of our test clusters. The light blue line all the way on the left-hand side from your perspective shows the read time coming off of Luster. And then we see that the read times on average progress downwards when we migrate over to using HDFS, followed by the two different revisions of our I/O system that encompass the scheduling algorithm within it. So this is basically where we stand right now. If anyone wants to play around with ParaView, it's available at paraview.org. And within the very near future, we'll be pushing this HDFS plugin out to open source if possible. So thank you.